Alright guys, in this video we're gonna keep going with the returns. Okay, we are gonna keep going with the model for portfolio return and portfolio weight optimization. So we need to keep going with the continue with what we had last time in the last video. So we have the returns downloaded using the link generator we created and the data import data from web function of Excel. So we have the data, and if you look at the data, you see that they are ordered in the time order. That is, earlier time is put at the top of the table, and the later time is put at the bottom of the table. We don't want that. I actually want to sort it from newest to oldest, so that I have this. The most recent data is at the top. The oldest data is at the bottom, so that I can calculate a return. So the return in October 2022 is basically the beginning of it's basically the adjusted close of October, right, divided by the adjusted close of September, which is a month ago, then minus 1. Okay, so I got the returns. So it's basically always the current month end of period return price divided by the beginning month the end of month previous period price, and we need to use adjusted close. So you may want to say, okay, why cannot I use the close divided by the opening and then minus 1? You cannot, and the reason is that you need the adjusted close. You cannot just use the opening. If there's something called adjusted opening, probably you can use that, but that's not something that's provided, so we just have to use the adjusted close. So if you look at the last one, you're going to see that we don't really have the data for the last one. Okay, we don't have the data for the last one, so we cannot really do it. So I'm going to delete the last one. So again, another question here is that, why don't we just have another month? Then if we do that, we'll have to have another one. Then we have to have another one. So it just goes on forever. We will just pause at November 2017. And for Apple, we do the same thing. Okay, so we first sort from newest to oldest. And then we have a column called return. And this return is the adjusted close of the current month divided by the adjusted close of the previous month, right? Then minus 1. Okay, so we have all the returns. Okay, so now we have the returns. What we need to do is to create another sheet. And in this sheet, what we're going to do, we're going to call it a model. So in this sheet, we're going to create efficient frontier using these two stocks. Okay, so how do we do it? So first, let's get the data in first. Okay, so to make it look better in this one, I'm just gonna put two lowercase x in column A, so that this column is just narrower. Okay, and then I can work on the other columns. So if there's anything that's overflowed, I can this little column can take them. Okay, so I want to have a column called date, and one column for Apple returns, another column for AMD returns, and these are the returns. And I'm gonna merge and center. Okay, so let's also center these. Okay, so the date, it just equals to one of the dates, whichever you want to pick. Maybe this one, it doesn't matter. And there are how many rows? There are 60 rows, right? 5 years, 12 month a year, so 60 rows. So we just need to go from 12 to 71. Okay, so we have 60. Okay, we have 60. So if you look at the last one should also be not there, and this one is not there, so we don't really need the last one. So in total it's just 59. So I'll take out these, so we have 59. So the returns is just the same as the returns in here. For AMD, it's the returns in the cell of AMD. It's here. Okay. AMD H2, Apple H2. Okay. So then select both, double click. It's gonna automatically fill all the data. Okay, so we have the returns. So the first thing I want to do is that I want to calculate some statistics. Okay, so for example, these are monthly returns, right? So I'm gonna create a combined cell and call it monthly AMD. And what about the monthly mean, standard deviation, and standard deviation? Okay, what about the monthly mean and the standard deviation? So the monthly mean is to estimate the mean of a historical returns. We just need to use the average of all these. Okay, so we have that. And for AMD, it equals to the average of all the AMD returns that are these. Okay, so and I changed the format a little bit, and you got these. Okay, so as you can see, the average return of AMD is apparently larger than the average return of Apple over the last 5 years, right? And then let's look at the standard deviation. So for standard deviation, we need to use the stdev.s, and S represents the sample. Okay, so I'm gonna select all the returns for Apple. Okay, as you can see, the standard deviation is 9.23%. Okay, and for AMD, all I need to do is just to copy this cell and paste it here, and it's automatically gonna scooch over for the AMD returns. Okay, so we have 17.09. As you can see, even though this one gives better returns than Apple, but this gives a much higher standard deviation than Apple. So then let's calculate the correlation, right? Correlation. And put it here. Okay, CORR, correlation. So correlation between Apple and AMD is just CORREL. That's the Excel formula. And I need to select two rays, ray number 1 and ray number 2. Okay, as you can see, I have 51.47%. So that's the correlation index. And I need a risk-free rate. Of course, I need a monthly risk-free rate, and let's just hard code it, because the key of this illustration is not really illustrate how to calculate or how to estimate the correct risk-free rate to use. The key is actually downloading the data, estimating the mean and standard deviations and the correlations, and then create portfolios with different weights in Apple and AMD. Okay, so then let's create the portfolios. So let's put it here. I'm going to select 1, 2, 3, 4 columns, and then it's going to efficient frontier, and we have the weights, and these are the merchant center. We have the resulted we have the resulted portfolio. Okay, so the weights on Apple and AMD should give different weights, should give us different level of portfolio expectation and portfolio standard deviation. So let's begin with 0% Apple and 100% AMD. So I'm going to use 1 minus, equals to 1 minus this 0%. Okay, so it's 100%. So basically in this portfolio, we put all our money in AMD and no money in Apple. And then I want to increase my weight in Apple by 2%, every 2%. Okay, so I can keep going. 32, 60, 90, 100. Okay, so basically I created 51 portfolios, right? So from 0% to 100% for Apple. So the remaining money will be put in AMD. That is 100% Apple and 0% AMD is our last portfolio. And in the middle, we have 50% Apple and 50% AMD. So half of our money is in each stock. So we also need to calculate the mean and standard deviation of these two portfolios. Let me center these. Okay. So how do we calculate the mean and standard deviation of portfolios? So now we cannot really do the average formula, right? We cannot use this because this is what we do when we need to estimate from the historical averages. Okay, so we cannot do that. But good news is we have an easier way to do it. That is, we can use the weight of Apple multiplied with the mean on Apple plus the weight on AMD multiplied with the mean on AMD. So it equals to the weight of Apple multiplied with the expectation of Apple plus the weight on AMD multiplied with the expectation on AMD. Okay, so be aware that I need to put dollar signs in front of the expectation of Apple and the expectation of AMD. I do not need to put dollar signs in front of the cell reference of the weights. The reason is that when we copy and paste, I want to lock the reference to the expectation, which is the mean of Apple and AMD, but I don't want to lock to the expectation of, sorry, I don't want to lock the reference to the weights. Okay, so I have this, which is a little too bad, so I need to make it a little shorter. So I want to do, how about I do this, and I also change everything else to 100 pixels, but I want to reverse this. Okay, so it's better, I hope. And that's the mean of the first one. Then I keep going. So if you look at the first one, the mean is the same as 4.41, which is basically correct because 100% AMD, 100% AMD. And if I look at the bottom, it's 2.71%. That's 100% Apple. So the mean is the same as Apple. So that makes sense. And then it's the standard deviation. The standard deviation, the calculation of standard deviation relies on the formula that you can find in the notes. So I'm not gonna go over that again. You just need to be extra patient when you are applying that formula. So the standard deviation of portfolio is basically the weight of the first asset squared multiplied with the standard deviation of the first asset squared, okay, plus the weight on the second asset squared multiplied with the standard deviation of the second asset squared, okay, plus the weight 2 times the weight on first one times the weight on the second one times the standard deviation of the first one times the standard deviation of the second one, then times the correlation between the two. Okay, so once again, this is the weight squared times the standard deviation of the first asset squared. I need to put dollar signs in front of it, plus the weight of the second squared times the standard deviation of the second squared, plus 2 times the weight on the first one, weight on the second one, then standard deviation, and correlation. Okay, so after that, this whole thing needs to be square rooted. Okay, so SQRT is the formula. So you put a square root of this. Okay, so if everything is correct, I should get 9.23. Oh, sorry, I should get 17.09%, which is the same as the AMD's standard deviation. Okay, so let me copy the formula and put it here, 17.09. So we are good. Okay, so if I screw down, the last one is 9.23. So it's 9.23, the same as Apple. So we're good. Okay, so we got the correct calculations. So that is the efficient frontier. So the key is we can plot the efficient frontier. So how do we do it? So the efficient frontier is plotted on the risk and expectation panel. So basically on the x-axis we have the standard deviation, on the y-axis we have the expectation. So I just want to plot the expectation, the mean of portfolio, against the standard deviation of the portfolio. Okay, so let's say, what if I insert a scatter plot? As you can see, everything is so messed up, right? So I don't want to do that. Let's, select different cell and then do this. I have a blank table, sorry, blank figure, and I want to put it here. And I want to select data, which is here. Click on it, and I got to select data. So I can add a series. Let's call it portfolios, and the x values should be the standard deviations, and the y values, y values should be the expectations. And I hit OK, and then OK. So I should get this. Okay, so I have a little curve, right? Okay, so that's the portfolios. So each dot on this curve represents a portfolio of that we can create using Apple and AMD. Okay, all right. So then I'm gonna play with it a little bit. So the first thing is I want to change the axis range. Got it. Okay, so the minimum, I don't want it to be 0%. I want it to be 0.08. Enter. Okay, so it looks better. All right, so I got it. So what if, let's say instead of correlation, this is a calculated correlation, right? What if I hard code it to 1? Not 1%, but 100%. What if I do this? As you can see, it's a straight line. Okay, what if I code it to 0%? You're gonna see a strong curvature, right? So what if I code it to -1? Sorry, -100%. I mean, it should be, blown off, right? So what I want to do is I want to change it back to 0. If I do that, as you can see, so there's a tip at the portfolio that's going to give us 0 standard deviation, which is a risk-free asset. Okay, so that's how correlation is going to affect the efficient frontier. So let's go back, more back. Okay, so this is the calculated correlation, and this is the efficient frontier we have. Okay, so the last thing I want to do is that I want to have a optimal portfolio. Okay, so I also select 4, merge it, call it optimal portfolio, and we have weights and portfolio. So I'm gonna select 2 and merge and center, select these 2 and merge and center, and AAPL, AMD, mean, STEV. Okay, so basically what I'm trying to do here is that I'm trying to look for the optimal weight, that's this cell. Okay, let me randomly put in a number, let's say 9%. I mean, I don't know whether it's the best number, but randomly. And then AMD, it's just gonna be 100% minus this 9%, right? It's the rest, right? Okay, and I'm gonna center these as well. So the mean of the portfolio, I think I can copy this and paste it here. As you can see, it's gonna be referring to L5 multiplied with C4, which is Apple's expectation, plus M5, which is the weights here, multiplied with D4, which is this. Okay, so it's okay. So we got it. So what about this? I put copy and paste. So I should get, the correct reference. Okay. All right. So if I change this to 0, so everything should update automatically, and it should map to one of the numbers on here, right? And then I want to calculate something called the Sharpe ratio. So what is the Sharpe ratio? The Sharpe ratio is the ratio of expected return minus the risk-free rate, that is the mean expected return, minus our risk-free rate, 0.25%, okay, then divided by the standard deviation of the portfolio. Okay, then divided by the standard deviation of the portfolio. If I hit enter, I should get something like this. This is a little too much. Okay, so okay, we have this. So what is the optimal portfolio? The optimal portfolio is the portfolio that's giving us the highest Sharpe ratio. So before we actually do the calculation, does it make sense? So basically, the Sharpe ratio captures the difference between expected return and risk-free rate in the numerator, right? What is that? What does that mean? What's the intuition of that number? That's basically the additional return you're getting for investing in this risky portfolio in addition to risk-free rate, right? So basically you're bearing risk, so you should be compensated for that much. And you divide by the amount of risk, which is captured by the standard deviation. So that's basically, this is basically telling us what's the unit return compensation for every unit of risk we're bearing, right? So so the higher this number, the more optimal the portfolio is, right? It means we are bearing the we are getting the highest amount of return for the risk we're taking. So we just want to maximize this. So how do we maximize anything in Excel? We need to use the solver. Okay, so I need to go to data, what if analysis, sorry, here, solver, data analysis, solver. Okay, so I want to maximize this cell L7, right? So I want to select L7 and I want to maximize it, and by changing this L5, okay, and I want to make it non-negative, so I check this box, make unconstrained variables non-negative. Okay, so then I hit solve. Oh, it found a solution. Okay, I hit OK. As you can see, it's 71% Apple, 29% AMD, and I can achieve a mean of 3.2% and a standard deviation of 10.04% with a Sharpe ratio of 29.4%. Okay, so this is our optimal portfolio. Okay, this is our optimal portfolio. So that's it. Okay, that's it. So that's it for this one. If there are any questions, let me know.